Hey y'all, it's Miss Michelle, and I'm going to be going over the 4.3 graphing polynomials with key points. So we're going to pretty much learn 2 more characteristics and a couple more vocabulary words that we're going to be having to find with polynomial graphs. Okay, so the first one is we are going to be finding the relative maximum, and I'm going to use a really mathy word here, and that's when we're going to be looking for the mountains, okay, of my graph. And then we're also going to be looking for relative minimums, which are going to be my valleys. Okay, and we're going to locate these 2 types of relative maximums and minimums based off their turning points. Okay, and turning points are not necessarily x-intercepts. They are where the graph is changing from increasing to decreasing directions. All right, so we have relative maximums looking for my mountains, relative minimums looking for my valleys. Okay, the relative maximum minimum is almost like the height of the function at our turning points. And so if we're talking about the height, that means I'm talking about the vertical axis, which is the y values. Okay, and then another cool little piece of information is the degree of the function is the number of turning points plus 1. Okay, so let's try our first example. I'm going to go identify my turning point. So if I'm looking at my function, I'm going up. I have a turning point here because I'm changing directions and coming down. Here's another turning point. Here's my third. And here's my 4th turning point. Now, don't forget what we've done in the past. We can look at this and say this is an odd function. So I know that my degree has to be like a 1, 3, 5, 7. Okay, or I can look at my x-intercepts. Okay, and I have 5 x-intercepts. But I can also now use this cool piece of information and take my turning points and add 1, which gets me 5. Okay, so there's multiple ways to find our degree. All right, so now let's go find our relative maximum. Okay, so I'm going to go look, and I'm looking for the mountaintop. So here's one of my highest points, okay, and here's another one of my highest points. So I have 2 mountaintops, therefore I'm going to have 2 values. I'm going to look at the y value. So my first relative maximum is 2. My second relative maximum is 1. Okay. Now I'm going to go look for my relative minimums, okay? So those are my valleys, and again, I have 2 valleys here, all right? And I'm looking at the y value, so that's -3 and -1. So those are relative mins and relative maximums. The next thing we're going to look at is the absolute maximum and minimum. Okay, so the absolute is either the highest point or the lowest point, okay? And these can actually only occur in even functions because remember, even degree functions either both ends go up or they both go down. We will not see absolute maximums or minimums in odd degree functions. Okay, so if I'm looking at my 2 examples here, let's start with this even over here. Since both of the ends are going up, I'm going to actually have a lowest point. So my absolute minimum here is -4. But if I look at my odd degree function over here, this function is going forever down and forever up. So I will never have the highest point and I will never know the lowest point. So we are going to say none for absolute max or min when we get to a odd degree function. If I can get down. Okay. All right, so let's try our first example. So example 1's asking me for my turning points. So I'm going to go, we're going down. I have a turning point here, another turning point here, and lastly, I have a turning point here. So I have 3 turning points. Okay. I do see that this is an even degree function. Okay, so again, I can go back to what we were learning earlier where I have 1, okay, here's a multiplicity of 2 because it's bouncing, so 2, 3, 4 x-intercepts. Or I can add 1 to my turning point and get the same answer. I have one mountaintop, okay? And what's tricky is this is a y value. So my y value here is 0. So that's a relative maximum. I have 2 valleys. So here's a valley and here's a valley. My first y value is -4 and my second is -1. So those are my relative. Now I'm looking at my absolute maximum, and that means I need to find the highest point this function will ever reach. But I see arrows going up on both ends, okay? So that means I will never know the highest point. So there's actually no absolute maximum, okay? I do, on the other hand, have an absolute minimum, okay? This is the lowest point this function will ever reach. So my absolute minimum is -4. All right, example 2, turning point. So here's my first turning point and my second. Okay, I know that this is an odd degree function because my ends are going in opposite direction. I can go look at my x-intercept. So here's 1, 2, 3. So my degree is 3, or I can add 1 to my turning points and get the same answer. I do have a mountaintop. Okay, so I have a relative maximum, which is going to be my y value at 8. And I do have a valley here, okay, which is at -4 on the y axis. Okay. But an absolute maximum, as I'm looking, this function is going up forever. Okay, so I will never know the highest point. So I'm going to write none. An absolute minimum. This point, or I'm sorry, this curve is going down forever. Okay, so I will never know the lowest point. So I'm going to write none.